So the question 1839, it says that the spool has a mass of 50 kg, radius of gyration KO is 0.280 meters, and 20 kg block A is released from rest. Determine the velocity of block when it descends 0.5 meters. So this is a spool of 50 kg, and then there's a block A which descends by 0.5 meters, and we have to determine the velocity at that instant. So for this we are given the mass of spool, which is 50 kg, the KO, the radius of gyration 0.28 meters, the mass of block A is 20 kg, and we have to find the velocity A, and the total radius is of 0.3 and the other radius is 0.2, and we have to use the conservation of energy rule over here. And as we can see in the diagram, this is block A in its initial position, and then it descends to a new position, that is state 2, which is 0.5 meters below. So if we find T1, the kinetic energy, which is 0, because initially it says that it is at rest, so kinetic energy is 0. And for T2, we know that this is a general plane motion. There is a rotation done by the spool, and then the block A, which is more translating by 0.5 meters during that instant. So we use a general plane motion equation for this, finding the kinetic energy, which is 1 by 2 IO omega square plus 1 by 2 MAV A square. So we'll put in the values. So the inertia is ms, the mass of spool, multiplied by the radius of gyration square, and for omega we convert it into V over R, so we can get an equation in form of VA. We know R, which is 0.2, and then we simplify our equation, which becomes 59 VA square. And then for V1, which is in this case it is in gravitational potential energy. So initially it said there was a rest, so the potential energy at the initial stage we consider it as a reference point, so that was 0. And then for V2, from that reference point it says that it descends by 0.5, so we use a negative sign because of that descending. And for WA it is actually the weight, so we multiply 20 with 9.81 to get it in form of newtons, and then we multiply with minus 0.5 due to that descending, and we get minus 98.1. Then we put in the values, so 0 plus 0, it's because of the T1 and V1 being 0, and 59 VA square is at T2 minus 98.1, which is the V2, and solving this equation we get VA, which is 1.289 meter per second, which is 1.29 meter per second.